Good evening. This is Rishik Ganta of registration number 19 BCE 1494 doing this video for the digital assignment 1 of blockchain and cryptocurrency technology. The topic that I am going to be speaking about today is Ethereum. The topics that are discussed in the slides are what is Ethereum, the features of Ethereum, and the applications of Ethereum. Ethereum. Ethereum is a blockchain-based distributed computing platform that enables developers to build and deploy their decentralized applications. It is a decentralized blockchain network powered by the Ether token that enables users to make transactions, earn interest on their holdings through staking, use and store non-fungible tokens, also known as NFTs, trade cryptocurrencies, play games, develop social media apps, and etc. Features of Ethereum. Ether. Ether is the Ethereum's cryptocurrency. Ethereum also employs smart contracts for developing applications and other software on the Ethereum blockchain. Ethereum virtual machine. Ethereum virtual machine provides the underlying technology, that is the architecture and the software for understanding and executing the smart contracts. Decentralized application. A decentralized application is also called a dApp. Ethereum allows you to create consolidated applications called decentralized application. Decentralized autonomous organization. Ethereum allows one to create autonomous organizations for democratic decision making. Ethereum blockchain. The Ethereum blockchain mainly consists of three elements. The transaction list, which is a list of all the transactions which are to be stored in the block. Then the second element is a block header. A block header is a group of 15 elements such as the parent hash, MS hash, beneficiary, state root, transactions root, recipients root, logs blue, difficulty, number, gas limit, gas use, timestamp, extra data, mixed hash, nonce, etc. The Omer list. Omer list is a list of all uncle blocks included in the block. Uncles or Omers. Sometimes valid block solutions don't make it to the blockchain. Any broadcast block up to 6 previous blocks back with a valid proof of work and difficulty can be included as an uncle. A maximum of 2 uncles can be included per block. Uncle block transactions are not included and just their header is included in the block. This was aimed to decrease centralization and the reward work given to the miner. Uncle headers can be included in the main block for 1 by 32nd of the main block miner's reward. And this reward is given to the uncle header miner. Miners of uncle blocks receive the percentage of main reward. Ethereum blockchain. Similar to Bitcoin blockchain, all the blocks are visible. However, the blocks have a different structure. The blocks in Ethereum are faster and the reward is different. One block in Ethereum can be generated or proposed every 12 seconds, whereas in blockchain it takes around 10 to 12 minutes. The main reward for proposing a block is 2 Ethereum currently. Miners can make a bit more money by including uncle blocks which are worth 1 by 30th of the Ethereum value, and they can include a maximum of 2 uncle blocks per block. The Ethereum blockchain uses ETH hash mining algorithm, which is different to compared to the Bitcoin algorithm. This algorithm helps mitigate ASCI and GPU advantages. It involves smart contract execution. The difficulty is adjusted every block and not every 2 weeks, like in Bitcoin. This is important to identify for the uncle block. This is an important identifier for the uncle block. The key differences between Ethereum and Bitcoin blockchain. The key differences are blocks keep track of balances and not the unspent transaction output, transaction outputs like the Bitcoin chain. Merkle and Patricia tries are used in the Ethereum blockchain. They have 3 branches compared to the Merkle tree's 2 branches. The Ethereum blockchain will transition from proof of work to proof of stake with the Casper protocol in the future. Ethereum nodes. A node in Ethereum will validate all the transactions and new blocks in the blockchain. They operate in a peer-to-peer fashion. Each node contains the copy of the entire blockchain. When an Ethereum node is employed as a light client, then they store only the block headers. These light clients provide for easy verification through tree data structure. They don't execute transactions and are used for primarily validating balance. Implementing the nodes can be implemented in a variety of languages like Go, Rust, etc. Ether. Ether is the cryptocurrency of Ethereum. It is the fuel that runs the network. It is used to pay for the computational resources and the transaction fees for any transaction executed on the Ethereum network. Like Bitcoins, Ether is a peer-to-peer currency. Apart from being used to pay transactions, Ether is also used to pay to buy gas, which is used to pay for computation of any transaction made on the Ethereum network and used to run the EVM, Ethereum virtual machine. Smart contract. A smart contract is a simple computer program that facilitates the exchange of any asset between 2 parties. The specified asset can be money, shares, property, or any other digital asset that one wants to exchange. Anyone on the Ethereum network can create these contracts. The contract consists primarily of terms and conditions mutually agreed upon by both of the peers or both of the parties. The smart contract's primary feature is that once it is executed, it cannot be altered, and any transaction done on top of a smart contract is registered permanently and is immutable. Smart contract versus traditional contract systems. In conventional contract systems, we sign an agreement and trust or hire a third party for the execution. The problem with this conventional contract system is that there can be a possibility of data tampering. With smart contracts, agreement is coded into the program, and the result is verified by all the users of the Ethereum blockchain network. And once the contract is executed, it cannot be tampered. Example of a smart contract. Let's take an example in which someone named Zach has given a contract of $500 to someone named Elsa for developing his company's website. The developers code the agreement of the smart contract using Ethereum programming language. The smart contract has all the conditions, that is, the requirements and the methodologies, etc., for building the website. Once the code is written, it is uploaded and deployed on the Ethereum virtual machine. Once the code is deployed on the EVM, every participant of the network gets a copy of the contract. When Elsa submits the finished work on the Ethereum blockchain for evaluation, each node on the Ethereum network will evaluate and confirm whether the result given by Elsa has been done as per the coding of the smart contract or not. And once the result is approved and verified, then the contract worth $500 will self-execute, and then a payment is made into Elsa's Ether or Elsa's Ether wallet. Ethereum virtual machine. Ethereum virtual machine is a virtual machine designed to operate as a runtime environment for Ethereum-based smart contracts. EVM is operated in a sandbox environment. Basically, we can deploy our standalone environment, which can act as a testing and development environment, and we can test our smart contract any number of times, verify it, and once we are satisfied with the performance and the functionality of the smart contract, then we can deploy it on the Ethereum main network. Any programming language in the smart contract is compiled into a bytecode which the EVM understands. This bytecode can be read and executed using EVM. Solidity is one of the most popular languages used for writing a smart contract. Once the contract gets converted into bytecode and gets deployed on the EVM, it provides security from cyber attacks. Gas. Gas is a term for the amount of Ether, the native cryptocurrency of Ethereum, required by the network for a user to interact with the network. These fees are used to compensate Ethereum miners for the energy required to verify a transaction and for providing a layer of security to the Ethereum network. To perform any transaction on the Ethereum network, a user has to make a payment to the miner in Ether via an intermediary token called gas. On the Ethereum network, gas is a unit that measures the computational work required for running a smart contract or other transaction. Transaction fee is calculated in Ether with the given formula, gas limit into gas price, where the gas limit on the Ethereum network refers to the amount of gas that is used for computation, and the gas price is the amount of Ether a user is required to pay. Proof of work versus proof of stake. Ethereum is in the process of moving towards proof of stake. This approach does not require large expenditures on computation and energy. Miners are now known as validators and post a deposit in an escrow account. The more escrow you post, the higher the probability that one will be chosen to nominate the next block. If you nominate a block with valid transactions, then we get our escrow back and also gain a small amount as a transaction fees. And if we nominate a block with invalid transactions, then we lose our escrow. One issue with this approach is that those that have the most Ethereum will be able to get even more and would eventually lead to centralization. On the other hand, it reduces the chance of a attack by 51% and allows for near instant transaction approvals. The protocol used for proof of stake is called Casper and will be a hard fork. Decentralized autonomous organization. A DAO or decentralized autonomous organization is a community-led entity with no central authority. It is fully autonomous, transparent, and the smart contracts lay the foundational rules for its work. Smart contracts execute the agreed upon decisions, and at any point, proposals, voting, or any other decision is made through is made through selling tokens and gaining a voting power. This DAO exists on the blockchain network where it is governed by its protocols and rely upon smart contracts. It manages decisions through smart contracts or voting system. The rules of DAO or how the DAO works. The rules of DAO are established by a core team of community members through the use of smart contracts. These smart contracts lay out the foundational framework by which the DAO is to operate. Once these rules are formally written into the blockchain, the next step for the DAO is to gather funding. DAO typically gathers funding through token insurance, by which means that the protocol sells tokens to raise funds and fill the DAO treasury. In return for the fees or buying the token holders are given certain voting rights and that are usually proportional to their holding. Once the funding is completed, the DAO is ready for deployment, and the DAO is then deployed onto the blockchain. Decentralized applications. Decentralized applications are also known as dApps. A dApp consists of a backend code that runs on the distributed peer-to-peer network or the blockchain. It is a software designed to work in the Ethereum network without being controlled by a centralized system. It provides direct interaction between the end users and, and the decentralized application providers. An application qualifies as a dApp when it is open source, that is, its source code is on GitHub and uses a public blockchain based token to run its application. A token acts as a fuel for the decentralized application to run. dApp allows the backend code and data to be decentralized. That is the primary architecture of any dApp. Other applications of Ethereum. Ethereum can be used in banking, in voting systems, and in shipping and agreements. Ethereum is moving towards proof of stake in the year 2022. Thank you.